good morning, or is it good afternoon? Some of you, it's more like good very late evening when you're watching these videos. For me, I got my Yeti mug, my coffee, and it is very early, but I work best in the morning. My head is clear. So today's going to be short and sweet. We are on lesson 14, page 35, and we are going to start real world practice. And we talked about these types of problems. They're real to an extent, it's like we don't want to get the word problems too complicated while we're learning the math. So when you are presented with a word problem and asked to write the equation, there's a couple tips that this note packet gives you. It says, look for words that indicate a rate or a comparison of two quantities. This is the slope, like $2 per cup, or 7 seconds, or what was it? 200 yards per second we had talked about with it when we did our racing. Look for words that indicate a starting point or an initial amount, something that is constant. This is the y-intercept. So for the lemonade, the y-intercept was how much money the girls started with, or really what happened with them is how much they spent, or the $20 they spent. That was their starting point. So let's take a look at example 1. A certain cell phone package for AT&T charges $85. Additional data used over the allotted amount adds 7 cents per, that means per, megabyte. So write a linear model, or an equation that represents this situation. So right here, where it says 7 cents per, and it's adding to it. So it's like you're starting with the $85. Oh, so that must be your y-intercept, right? You're starting with the $85, and then if you go over what they allot, then you're going to be charged an additional 7 cents per megabyte. So this is your slope. So we're going to write the equation using y equals mx plus b format. So you're just, oh, sorry when I do that. I can't help it. All right, y equals m, which is 0.07 times however many data points you're over, I guess, and then ever megabytes you're over, and then plus the $85. So you're not going to be paying any less than $85 for your bill. And the way they calculate your bill, if you look below it, is, well, how much are you going to spend if you use 300 additional megabytes this month? So you take your equation, and this is of interest, believe me. I don't know if I necessarily write my bills down exactly like this, but we talked about how I could figure stuff out in my head to figure out what somebody's going to charge me. So y equals 0.07. You have the 300 megabytes, so you're going to replace x with 300 plus 85. So 0.07, hello, 7 cents. Don't do 70 cents. That'll really mess you up. That'll really mess you up. Is this right here is $21. So that is not how much you're going to pay. You're going to pay $21 plus the original $85. And that's what your bill for that month is going to come to, which is what? $106. I will spend $106 if I use 300 additional minutes. This might not be necessary, but sometimes, sometimes they ask you to write it out in a sentence. All right, example 2. All right, this is a common little question, right? To the student council with the t-shirts, but this is a little different. So read the whole thing. So student council is selling Spirit t-shirts. You can see it. During, sorry, I'm trying to get, whoa, you're making me sick. Sorry. Okay. I'm trying to figure out this camera thing still. And when I have to get the whole page, it's tough. Student council is selling Spirit t-shirts during Spirit Week. There is a one-time fee. There it is, one-time fee of $20. That is a key. That is your y-intercept. What's the symbol for y-intercept? B. So I don't feel like writing it all out. See, isn't that convenient? So it's a one-time fee for the design, and it's $5 to print each shirt. So each time, so each is your kind of a word that's indicating that it's a comparison of two quantities that's happening again and again and again. So this is your slope. I was checking to see how they worded up top. So write an equation or write a rule for the linear relationship to show this situation. So you're going to do y equals mx plus b. You're going to replace m and b. So y equals, what's the rate, the 5 or the 20? Well, the 20 is the one that's where they, that's the one-time fee. That's like where they're going to start. So they're going to start with the $20. They're only going to charge that one time. And then to the $20, they're going to add $5 per shirt. So $5 times X. And then you can go ahead and use this to determine, okay, well, if the student council decides to purchase 150 t-shirts, then how much are they going to have to dish out, right? So y equals 5x plus 20 for 150 t-shirts. Y equals, so it's going to be 5 times 150. Then they have to pay that design fee, right? So what's 5 times 150? Punch it in. I already did it. It's $750 plus the $20. And so for them to get 150 shirts, it's going to be $770. Oop, guess I do that backwards thing. $770. So they better be charging enough. They better be charging more than $5 for the t-shirts, right? When they go to like sell them, they got to make up for the $770, right? Okay, that's it. There is no exit ticket today, but we're going to do the second part of this lesson tomorrow, and there will be an exit ticket for that. But for today, I was thinking maybe you could make up your own little story, something that has a starting point and a charge like per hour, per second, whatever. Your own little linear relationship problem and write it right here with an equation to model it. So my best example so far is our lemonade, right? The girls went and spent $20 and they charged, let's say, $2 a cup for lemonade. I'd write that down. And then the equation for that would be y equals 2x minus 20. Remember we talked about that since like day one? Maybe you could think of your own story, kind of like my lemonade story with whatever you want. So that is your challenge for today. Good luck.